So far we've only dealt with whole numbers in this course. It's now time to start looking at floating point numbers. Now what I've done here is I've created a new project called Float and Double. So let's go through now talking about floating point numbers. So unlike whole numbers, floating point numbers have fractional parts that we express with a decimal point. 3.14159 is an example. So floating point numbers are also known as real numbers. We use a floating point number when we need more precision in calculations. So there's two primitive types in Java for expressing floating point numbers, and that's the float and the double primitive types. The float is a single precision number, and the double is a double precision number. So precision here refers to the format and amount of space occupied by the relevant type. So single precision, and that's the float primitive type, occupies 32 bits or 4 bytes, and as per our discussion previously of width, that means it's got a width of 32. And a double precision, and that's the double primitive type, is double that, so it occupies 64 bits or 8 bytes, and thus has a width of 64. And you can see on the screen there the float and the double ranges there, and that should confirm to you that the double is basically has a much larger range and more precision than the float. Alright, so now that we're back at the code, let's confirm what we saw on the slide, what those ranges were, and do something similar to what we've been doing for other primitive types by using their min and max values. So what I'm going to do now, I'm going to double click up here, and if you do that, that puts the code on full screen, and I'll try and do that for all future videos just to make it clear, because we don't usually need the project pane open, and if we do, we can just open it for that purpose. Alright, so I'm going to start by typing float. My min float value is equal to float.min underscore value, and we'll do the same for max. My max float value is equal to float period max value. Let's print both out. I'll go float minimum value is equal to plus my min float value. And you probably notice as we're going through the course now, as we've gone through a concept a number of times, I'm not going to repeat and say all the code. So in that case, I didn't talk about the double quotes. Because we've done this a few times, that should be hopefully coming second nature to you. And likewise for the abbreviations for S out, I'm just typing those now, assuming you are familiar with those now. So we'll do the same for float maximum value equals, and then we want my max float value. All right, and then the other thing we'll do is we'll just take a copy of that, paste the code in, and we'll just do a quick search and replace and do the same for the double primitive type. So we'll replace float with double. You've seen me do this before now, making sure match case is checked, and the same for the uppercase version. Okay, replace all. All right, and we'll close down the replace window. Search and replace window. Alright, so we've now got the capability to check those minimum and max values for both the float and double primitive type. So let's do that. We'll run the code, make sure that it works. Okay, and there's our output. I'll just put that up a little bit more so we can see. Okay, and that confirms the ranges that you saw on the slides. So you really can see there that double can work with a much bigger range of numbers, and it's also a lot more precise than the float. But of course, on the other hand, it needs twice the amount of memory, 64 bits or 8 bytes, to store that number compared to the float, which requires 32 bits or 4 bytes to store its number. Alright, so let's move on now. Let's actually start typing in a bit of code. And what we're going to do now is start having a look at how to use some of these variables, and we're going to actually add an integer, and you'll see why later on in the video. My int value, we set that equal to 5. We'll do the same for float, so my float value is equal to 5, then double my double value equal 5. Now notice that I haven't put anything on the end there. We haven't put an F or a D or anything there, and that's been accepted. In general, the double data type is accepted as the default, much in the same way that the integer data type is accepted by default for whole numbers. So we can also put a D there or an F there to confirm that, and it's good practice to do that in general if you're typing in literal numbers to make it abundantly clear of the meaning. Alright, so that's a way of declaring the three variables, the int, the float, and the double. Now that works fine for a whole number, but you'll find that if we add a number with .25 for 5.25 decimal, and if I remove the F there, we'll actually get an error. Now the reason is that the double is assumed to be the default floating point number, so we've got a similar problem that we saw with other data types in previous videos. And if I hover over that, you can see that it's requiring a float, in this case a literal value that we've typed in, and it found a double. So you can see there that by default a floating point number is assumed to be a double by Java. Right, so quick challenge there for you. Thinking back to our discussion on casting, which if you recall we used to convert an integer both back to a byte and then again to a short, how do you think you'd do the same for the float to remove this error? So have a think about that, pause the video and try it out and see if you can get it to work and to remove the error. When you're ready, come back and resume the video and we'll go through the solution. So pause the video now. Okay, so welcome back. Let's get this working, and we need to use a cast. If you remember, the format of the cast is left and right parentheses. So I'll start with the left one, the name of the data type you want to convert to, float, and I write parentheses, and I usually put a space there just to make it clear. So what's happened there is the error has disappeared, as you can see there now, and that's because we're telling Java, yes, this is a literal double that's been typed here, but we want you to treat it as a float, and for that reason, the error then disappeared. Generally not recommended to do that. Well, there's two reasons. Firstly, as I'll talk about in the next video, floats aren't usually recommended to use much these days. Double is the preferred floating point data type to use. But secondly, it's a lot clearer. I think you'd agree, comparing that to adding an F on the end there. It's just easier, there's less to actually look at, and the F straight at the end tells you, okay, that's a float. And that's generally the format that most programmers would use. They would use an F to indicate the type rather than trying to cast it, which is just a little bit more code to look at. All right, so let's finish the video here. In the next one, we'll start exploring more about these floating point types, and we'll start doing some division to see what happens and what those numbers look like. So I'll see you in the next video.